These are the pre-calculus class notes for section 1.5. We'll be going over examples more on slope of a line. Again, these are the learning objectives up here, and also please make sure you've read through the e-text to get a full and complete understanding of everything in this section. So these are the examples I've constructed to run through with you. The first of these, write the equation of the line in slope-intercept form passing through this point, -3, -1, and parallel to the line y equals -1/2 x minus 5. So the first thing to know is that parallel lines have the same slope. In other words, if I have a line with a slope of m1 and another slope with a line with a slope of m2, these have to be the same, right? Parallel lines, the slope have to be the same. So what do we know? We know a point on the line, and we also know its slope because we know we want it to be parallel to this. So we know that the slope we're looking for is the same as the slope of this line, which is -1/2. So given that we know a point on the line and the slope on the line, we want to use the point slope form for the equation of a line. So y minus y1 would be y plus 1 equals the slope, which is -1/2 times x minus x1, which would be x minus a -3 or x plus 3. Then you just simply solve this equation for y to put it in slope-intercept form to end up with y equals -1/2 x minus 5/2. In the second example, we want to write the equation of the line in general form. Now, general form, remember, is the form of ax plus by. Some people write it as equals c. Your author here likes to write it as ax plus by plus c equals 0. So that's what we'll be looking for the general form. Okay, so we know that we have a line that's going through this point and it's perpendicular to this line. So we need to see what the slope of this line is and understand what it means to have a line that has this perpendicular to that line. So let's review that real quick. We have perpendicular lines. Perpendicular lines have what we call negative reciprocal slopes. So if we know one line, let's say we know the slope of m2 here, this line, that means m1 will be equal to -1 over whatever m2 is. So let's take the equation of the line that we want to find a perpendicular line to, this 3x minus y plus 4 equals 0. We solve that for y to get y equals 3x plus 4. Okay, so what do we know? Well, we want to construct the equation of the line which has a point of -5, -3, so that's our x1, y1. And we want to have a slope that puts it perpendicular to this line. So since this line has a slope of 3, -1 over 3 would be -1/3. So the slope that we want for the line we're trying to construct is -1/3. Now we have our point, we have our slope, we put it into the point slope form. We do some basic algebra and we solve it into the form that we have ax plus by plus c equals 0. Now when you do that, when you first solve this from what we have from the point slope form, you would get 1/3 x plus y plus 14/3 equals 0. I noticed that on my math lab a lot of times they want you, if possible, not to have fractions involved. So since when we do have a fraction we're dividing by 3, we want to multiply the entire equation by 3. That then gives us x plus 3y plus 14 equals 0, and that's probably the most simplified form in the general form there. Okay? The third example was to find the average rate of change of a function between two values of x. x1 is 2 and x2 is 6. So you have to know what does it mean to have the average rate of change of a function. It's really a definition. It means that I want to know on average, what is the slope if I connected the dots between the 2 points? What's the slope of that line if I were to connect the dots between the 2 points on the function I'm interested in? So from x1 to x2, the slope of that would be change in y over change in x. Well, change in y is the function at x2 minus the function at x1. That's change in y divided by change in x, which is x2 minus x1. So the average rate of change of a function is the slope of a straight line if I draw a line that are connecting the two dots, the 2 points on the function at a starting x value to a finishing x value, or this formula here, okay? So the function we have is x squared minus x plus 4. So if I'm looking at f of x1, I want to plug in f of 2. I get 6. f of x2, I want to plug in f of 6. I get 34. By the way, again, it doesn't matter which guy you label x1 and which guy you label x2. In this example, you were told what they were, but it wouldn't matter in general. Okay, so plugging it into our formula for the average rate of change of a function, we get 7 after simplification. The last example in this section is the graph of f passes through 2 minus 5 and is perpendicular to the line that has an x-intercept of 4 and a y-intercept of minus 1. Perpendicular to the line that has an x-intercept of 4 and a y-intercept of minus 1. We want to write the slope-intercept form of that function. So in other words, a line. So coming down here, we want a line that goes through the point 2 minus 5. So that's our x1, y1. And we want to have a slope of minus 4. Okay. Why? Because the line we do know has a slope of 1/4. So the negative reciprocal of 1/4 is minus 4. Right? Flip the 4 and the 1 and make it the opposite of what it is. So that means that using the point slope form, we come down and simplify after we plug into the point slope form our y1 and our x1. Simplify, solving for y to get it in slope intercept form, y equals minus 4x plus 3.